Alright, our last video is going to deal with enzymes. So enzymes, if you remember from our last unit, these are all proteins. So these are made up of proteins. And their job, the thing that they do, is to speed up a chemical reaction. So before we actually get into enzymes themselves, we have to take a step back and understand what a chemical reaction is, or review what a chemical reaction is. So in any sort of given chemical reaction, you are going to be changing something or some things into other things. So sometimes it can look like this, where you have two things changing into two other things. Sometimes we can two in one. But either way, what you need to look for first when dealing with a chemical reaction is this arrow. So this arrow is going to tell you what direction you need to read in. Sometimes you'll have the arrow going right to left. So you need to know which direction you are going to read in. Now, on the end of the arrow, the not pointy end of the arrow, so these guys here, these are at the beginning. So this is your before, and this is your after. So the things that are at the beginning, the things that are reacting, are called your reactants. And only in the case of enzymes do we call these by something else. We call these substrates. But everyone else in science, as chemists and so on and so forth, are going to call these reactants. When we are discussing enzymes, we're going to call them substrates. Okay, and now the thing at the end. This is the thing that you are producing. So this is your product. The thing that you are producing, the thing that you are making. Okay, so now let's talk about what happens on a molecular level. So when you were talking about all the atoms and talking about all of these molecules, what ends up happening is that every time we put two things together, so let's say these two things together, what we're doing, like in a dehydration synthesis, is we are joining them together. When we are joining things together, we are making this thing, making a bond. Each time we make a bond, this is going to store the energy. This, if you eat more than you need to, is how you gain and store all of your extra energy to build your fats, to build your fat cells and so on and so forth. So when you're making a bond, you're adding to yourself. So this is going to store energy. So that means that to go the other way and break a bond would be to release energy. Why do I talk about energy? Because you can kind of graph the reaction process. So as the time goes on, right, you may see something like this, where the y-axis is talking about energy. So as energy increases, as time increases, you might see changes in energy levels. So in this case, we started out with two different molecules, and together they're relatively low energy. But when we add this energy in, we realize we have just stored all of this energy. That's what's being stored. So this time tells me that this is the before the reaction, and after the hill, it is after the reaction. So when I'm talking about during a chemical reaction, the actual physical process, here, my products, my two green molecules, my two green molecules are here, and at the end, this is what happens. So as time goes on, it turns from these two into this one molecule, and their energy before was low, and now it's pretty high energy. So what is this hill in the middle then? Well, you see, in order to make a bond or to make any sort of chemical reaction, you're going to need to input some energy. So this is the added energy by you in order to to actually complete your process. This is called your activation energy. This is how much energy you need to put in as a person, as a person to put these two molecules together. You gotta give it some push before it can roll down the hill. Okay, so why do I discuss this? Because sometimes this reaction requires such a high level of activation energy that you just don't have it. So it makes it really hard for it to go from here to here. It's very slow to get from here to here if your hill is really tall. Imagine pushing a ball up a hill. If you were to push a ball up a hill, it would be harder for you to push this ball up and over as opposed to a smaller hill, right? Assuming same ball. So this one here, if we use the hill analogy, is going to run faster than this one, which is going to run slower. So that's why when we talk about enzymes, when we say it speeds up a chemical reaction, what it's actually doing, it's taking this hill and it's not making it go away completely, but it's just making it smaller so that your reaction can go from point A to point B a little bit quicker, so you have more product at the end for a given same amount of time. Okay, so what does an enzyme actually look like? Let's talk about that for a little bit. Your enzyme is a protein, meaning it's a rather large molecule and it could have some shape. Let's say it looks like this. This is my enzyme. Enzymes can come in all shapes and sizes, so don't think that they all look like this. So here's an enzyme, and my goal as an enzyme is try to help this guy become two individual products. So this is my goal. So this is my chemical reaction. So this is the thing that normally happens. That is the chemical reaction that wants to happen. Right here. Okay. So your enzyme, if you'll notice, has the exact shape here as the outline of my reactant, in which case we call a substrate. So it's still a reactant, but now we call it a substrate. So what this means is this substrate is going to fit into your enzyme, so that your enzyme and substrate are going to come together and look a little bit like this. It's going to come together and look a little bit like this. So there's substrate, and this is your enzyme. And then your enzyme is going to take this and help it to break up into its components, but your enzyme at the end is still going to be there. So what you'll see is at the end, you have these two products. Plus your enzyme. Your enzyme didn't go anywhere. In the beginning, you have your one substrate, in this case, plus your enzyme. In the middle, we have something called an enzyme substrate complex. It's just a big fancy word abbreviated to ESC that just says it's your enzyme plus your substrate merged into one. Okay, so you notice at the end you have an enzyme. At the beginning you have the exact same enzyme. Even though your substrate turned into your two products, your enzyme was not used in the chemical reaction. So your enzyme, this means your enzymes are actually reusable. You can use these over and over again until you are out of substrate to make into products. So enzymes are reusable. Now your enzymes can only fit this one thing. So have only one type of substrate. So you'll see here that can actually fit. So you see here that it's got a shape. The only substrates that can fit in here are the ones with this exact shape. That means that if you have this enzyme, but you have this substrate, this one can't actually go in because it's the wrong shape. It has to be the same shape in order for it to actually bind and connect. So it's got a wrong shape, it can't fit in. That means if it only has one substrate, it can only do one job. Has only one job. It can only take this one substrate and make it into two products. Sometimes it takes in two products and make one substrate. So it depends on the enzymes. It could go this direction. It could also go in this direction. Depends on the enzyme, depends on the substrate. So it's not always breaking up something. Okay. Okay, another thing about enzymes is that because they are so dependent on the shape, because shape is so important to the enzymes, if they lose the shape, then they lose their job. If they lose their shape, they lose their job. So that means they also have enzymes have an optimal condition, have an optimal environment. Remember that optimal just means best. They have a best or favorite environment for them to work best in. Environment for them to work best in. And when we say environment, we mean temperature and pH. Temperature and pH. So they really like being at a certain temperature and a certain pH, just like how you have your favorite temperature room as well. If they are to lose their shape, for some reason, they may denature. If they denature, it just means they are broken down and then become unusable. If they are at different temperatures or different pH. And this is why, going back to our human bodies, we absolutely need to maintain homeostasis, which, as you remember, is just our internal environment. For example, our pH and temperature, so that our nice and beautiful enzymes do not denature. So this is what you don't want. You don't want them to be denatured. You don't want them to be broken down, because then they become unusable. All right, that concludes the topic on enzymes, as well as all of Ms. Guo's information about Unit 2 Biochemistry. If you have any questions, feel free to email me. You know my email. It is the one at pwcs.com. It's on your syllabus. Find me there. All right, thanks guys. Good luck studying, and I will see you soon.